Hello guys, I hope you are doing well. I started another lecture and teaching. Oh, I turn on the laser pointer about the exergoeconomic and exergoenvironmental concept. I am a Mehdi Ali Ehyai. This is another new course that you can, for example, follow up this teaching method that maybe is useful for you. Anyway, at the first step, I should introduce you the what is the exergy. Exergy is a maximum useful work possible during a process that bring the system into equilibrium with the heat sources. And also, we have three types of the exergy: physical exergy, chemical exergy, and also potential and kinetic exergy. For example, if I want to, for example, briefly define the exergy, the exergy encounter with the quality of the energy, but the energy is also solo rely on the quantity of energy. This is the, for example, the big difference between the energy and exergy. So I go to the another slides about that's for example in this slide we compare the exergy versus the energy. The first step about the comparison between the energy and exergy. Exergy is converted and also based on the first law of the thermodynamics, while the exergy is based on the second law of the thermodynamics. And also exergy accounts for energy quality and also usable that for example but in the future in the following in the future slide I introduce you the difference between the energy and exergy. And also energy cannot be destroyed, and but the exergy can be destroyed. For example, because that imagine that you have a wind energy, that for example wind follows and you have a wind energy. In this case, for example, you establish a wind turbine, and the blades of the wind turbine rotates due to, for example, wind flows, and also the electricity is produced. So, for example, in this case, that for example the electricity is produced, and also we know that electricity is a useful energy. But also, for example, the big difference, but we have a main difference between the energy and exergy. For example, if we have wind flows, for example, in the several places, region, and country, this is not a useful energy, and also. Um, and also the exergy of the wind flows is equal to zero, except that we converted it to the electricity or any other useful power. In the another example, for example, I give you a very simple example about the difference between the energy and exergy. For example, you imagine that you have a one bowl with the hot water, and you put it on the table. It is quite clear that heat is dissipated from the boiled water to the environment. And also, for example, I have a one question. This hot water in the bowl has energy? Yes, certainly has energy. But also, for example, it has exergy? No, it does not has any exergy. Because we cannot gain any, for example, useful work from this boiled water. And imagine that, for example, you have a one bowl and also you put hot water in it, and also you use, for example, this hot water, for example, for warming up the food. In this case, we have exergy because we have a useful work and energy, and convert also for example, and also because in this case the target is warming up the food. So we have exergy because we have a useful work, and we gain a useful we can use the for example the energy content of the boiled water for the target of the warming of the food. So in this case we have exergy, but in this case in both cases we have energy, but only in this case we have a exergy. About the general exergy equation, that you can see the general exergy equation, which is divided into several matters. And also I should emphasize that zero subscript zero means the dead point, because in calculation the exergy we must have one criteria, and that in this case the criteria is the dead state. But also definition of the dead states varied from the one condition to another condition. For example, in many cases, for example, the 20 or 25 centigrade temperature is, for example, the dead state definition for the temperature, and also one atmosphere pressure is the definition for the for example dead state. And also we have another for example another part here about that's chemical. This part is related to the physical exergy, and also we have two other parts, this part and also this part, which is related to the chemical exergy. In this part, we multiply the mass ratio by the chemical exergy. That for example, this is a for example, this is a one number that you can find it in several tables. That for example, which is related to the chemical exergy for formation. But also, for example, several molars. For example, in this case, the X and this I is a mass molar or mass fraction, and also yi is xi is a mass fraction, and also yi is a molar fraction. And also this case is related to the for example exchanging between molars in the for example in the exergy. For example, you imagine that you have a one mixture, for example, of the HO2, CO2, and CO. Also, for example, for calculation the chemical exergy, we should calculate this, which is related to the chemical exergy. And also we can find the chemical exergy formation in the several tables, and also in the internet. It is a constant number, and also we have a exchanging between molar and mass fraction for the one mixture, that you should at first calculate the xy and iy, and then calculate this item. So these two items is related to the chemical exergy. Beside that, we have another option about the GZ, which the GZ, and that's fractional G means the gravitational acceleration, which commonly which is equal to 9.81, or for example in the simpler cases is equal to 10, and also the Z about the height of the one system from the one criteria or base point. This item is related to the potential exergy, and beside that, we have another option about the, for example, v means that velocity, that power 2 divided into 2, which is related to the kinetic exergy. So, for example, in summary, these two items is related to the physical exergy. This item is related to the chemical exergy. This item is related to the potential exergy, and also this item is related to the kinetic exergy. But also, I should emphasize that in the based on my experience. I should emphasize that for every systems, for example, we should not calculate all of these items. Only some of these items are enough. For example, not for example calculation all of these items. Oh, in this slide, you can see, for example, that it is based on my previous explanation about the previous slide. This item is related to the physical exergy. This item is related to the chemical exergy. This item is related to the kinetic exergy, and this item is related to the potential exergy. Each term accounts for a different form of the useful work potential relative to the environment. Also, in this case, but I think for example, I told you that all of us, but another time for this equation in this slide, you can see the parameter definition. For example, H related to the specific enthalpy, S is related to the specific entropy of the one stream, and also H and the 0 and S and the 0 is related to the enthalpy and entropy and the environmental state or dead state. Uh, T0 is related to the ambient temperature. Dead state, Xi is a mass or mole fraction. No, no, no. Y is a mole fraction. Oh, I have a mistake here. Xi is related to the mass fraction, and also Ex and this Hi is related to the standard chemical exergy of the species I. G is related to the gravity, acceleration, and also Z is related to the elevation. And also V is kinetic exergy. V is related to the velocity. And also R and this I is a gas constant for a species I. For example, in any cases, you should divide the general gas constant, which is equal to 8.314 divided into that's molecular mass of every component. And also Yi is related to the mole fraction of the species in the mixture. Yes, for example, I think that's for example, I think only this point is very important here about the equation of the chemical exergy that I explained to you. Uh, all of us, Xi is a mass fraction, Hi is related to the chemical exergy formation, which can be found that in the several table. T0 is related to the dead state, Xi is related to the mass fraction, Ri is related to the gas constant, and also Yi is related to the molar fraction. The chemical exergy accounts for the chemical composition and also irreversibility due to mixing of the components. But maybe one question arises in your mind that when we should use this, for example, this equation, for example, in the some reactions such as, for example, I don't know, mixing and also the combustion, and also something like that. In general, when in the one system, one chemical reaction happens, you should use these items. About the physical exergy, that's you can see it, and that's about the equation h minus h is denotes the enthalpy, h0 denotes the enthalpy at the dead state, t0 is related to the temperature of the dead state, s denotes that's the entropy, and also s0 denotes the entropy at the dead state. This equation represents the maximum work potential due to temperature differences with the temperature, and also pressure differences with the environment. And also, for example, this item in the exergy calculation happens, and you must calculate it in the majority of the systems, because in every system, for example, imagine that you have a one C system. It is quite clear that you have some inlets and also some outlets, and also, for example, changing in the temperature and pressure happens. So for the inlet stream and also for the outlet stream, you should calculate these items. Another question about the represent velocity power 2 divided into 2 represent the work potential due to velocity of the S stream. This equation is related to the kinetic exergy. For example, it's also widely used in the calculation the potential on the kinetic exergy. For example, in the wind turbine, and also, for example, in every point that in summary and in conclusion, in every systems that between inlet and outlet you have, for example, variation in the velocity, not for example very small variation in the velocity, but you have, for example, huge differences in the velocity, you should calculate these items. That, for example, imagine that you have, for example, these systems that, for example, the inlet S square is quite different from the outlet S square. Excuse me, the inlet area is quite different from the outlet area. In this case, you should calculate the kinetic exergy, and also in the wind turbine. And also, for example, we have about the potential exergy, that general, that's gravity is multiplied by the height, represent the work potential due to elevation differences, and also gravitational potential. That, for example, you imagine that the water that, for example, in one system, for example, in the dam, you have huge height differences. In this case, you should calculate the potential exergy in the inlet and outlet. So in this case, for this section, I think it is enough. I hope you have a nice day. That, for example, in the recent days, I have some pause in my, for example, teaching. I am so sorry about it due to, for example, bad duration. Anyway, I hope you have a nice time, and I hope your health success in your life. And goodbye.